Hello, everyone, and thank you for joining us. Today's webinar, United in Possibility, Unleash the Full Potential of RAN Energy Savings, presented by Senza Fili and VIAVI Solutions. Our speakers today are Monica Paolini, Principal at Senza Fili, and Frank Mamani, AMS Product Line Management at VIAVI Solutions. Today, we will watch presentations from each of our speakers, followed by a Q&A session at the end. We would like to encourage our audience to participate in the conversation. Please share your comments and questions using the Q&A button at the bottom of the Zoom screen. All comments are visible to all participants, so please keep the conversation polite and respectful. And feel free to ask your questions at any point during the presentations. Our speakers will do their best to address them during the Q&A session at the end. With that, I'll hand it over to Monica.
Thanks, Kendra, and thanks for VIAVI to sponsor and participate in this event. This is a very interesting and fascinating topic, and because energy consumption, it's more than just reducing a little bit of cost or increasing efficiency. There is a lot more to think about. So I guess that the reason why it is becoming such a top topic for everybody involved in telecoms is that for operator, it has become really, really important. They never wanted to waste energy, but in the past, it was just less of a concern. Why is it a concern right now? So, well, first of all, it's a very good way to reduce OpEx. So that's simple. But also there's a lot of commitment for many operators to reduce consumption to meet sustainability targets. So, for instance, Verizon has a net zero emission goal by 2040, Vodafone the same, Telefonica by 2030. Verizon and Vodafone want to reduce their carbon intensity by 2025 by 20%, 70% by Telefonica at 2030. Telefonica seems to be generally a little bit more aggressive than others. And this is just examples because pretty much all operators will have a target. And then also there's a plan to increase the shift to renewable energy, and also an improvement in the consumption per traffic unit. And we will get back to it because it's not just how much power we consume, but also how efficient, and it's actually more important, how efficient are we in doing that. And here you can see also, how important it is for them. It's energy efficiency, sustainability is more important even than security. So that gives you a sense of how important that is. And there is an inherent issue as you deal with the power efficiency, is that we are in an industry with an incredible growth. So the traffic growth increases. So it's very difficult to reduce power consumption as you try to do more. And so how can we do that? How can we pull this off to decrease consumption as we increase the traffic load? So now, why now? Why not 5 years ago or 5 years from now? And so sustainability has become a top concern because of climate change, an increased awareness and concern from everybody involved, from government, people, so it's across society. Then that also leads to OpEx reduction, which is always helpful. But I would say that that's really the OpEx reduction is particularly important because of the current increase in prices. So if you see here in the graph, you can see that the wholesale prices in the European Union is increasing very quickly. So that clearly is a concern. And it's not only the cost of electricity, the cost of power, but also the potential availability and disruption. So this is really, there's a lot of motivation for the operators to really look at how to increase the efficiency. And this is especially true for countries with high energy costs, but even the ones that do not face that challenge right now, they know that they could be facing it tomorrow or a year from now, in the same way that European Union was not expecting this to happen right now. Now, when you think about reducing power consumption in the wireless network, the RAN is the most important focus. And this is because 73% of power consumption, according to GSMA, comes from the RAN. So if you're a mobile operator, you want to cut energy consumption, that's where to go. And the power consumption accounts for 35% of the OPEX. So overall, power costs are 26% of the overall OPEX for an operator. So it's an important cost element. Now, also keep in mind that more than 70% of the RAN energy is not directly coming from the wireless equipment. It's from cooling, fans, UPS. So even if there is the equipment uses less power, you still have to deal with all these other elements. And so the increase in power efficiency there might not be increasing very quickly. So the RAN is the key element, but RAN equipment is not the only way or not the primary way to reduce consumption or to be power efficient. Now, this is the other step that oftentimes when we look at reducing, well, we also think about, let's try to reduce power consumption. I think that we need to really shift the thought about to energy efficiency. Now, since usage is going up, as I said before, we need to be realistic in terms of what we can accomplish. And the use of the wireless infrastructure, so the wireless connectivity actually leads to energy savings in other verticals, in the rest of the economy and society. So it's a good use, so to say, of energy, but at the same time, we need to keep in mind that we need to increase the efficiency rather than the energy consumption per se. Now, the other, and this is connected to the fact that oftentimes what you hear is, or what we know, is that as you move from 2G to 5G, the power consumption for each base station increases. And this is what you see here. And this is a clear fact. You have more at the cell site. So the cell site does more, uses more channels, and 5G requires more power because it uses more efficient technology. However, the efficiency of 5G is higher because the consumption per bit or per unit of traffic is lower. So while it is true that 5G uses more power than previous Gs, it's also true that it's more efficient. So we shouldn't see 5G as taking us backwards. It takes us forward in terms of efficiency. So we need to think about it in terms of what is the best way to increase the efficiency rather than the total. Now, one other thing is that also what that tells us is because 5G is more efficient, decommissioning all networks is going to be a way to to increase power efficiency. Now, what that also means is that we need to think about energy efficiency as a strategy, as an overall strategy that goes also beyond RAN, but also goes beyond just the equipment. So here is a sort of a few general points, and Frank will go into much more detail in terms of addressing them. So again, it's not just trying to reduce energy here and there. That's certainly it's a good, nothing wrong with that, but we need to have a sort of a higher level energy strategy. And clearly RAN is the first target, but again, we need to think more than equipment efficiency. And because we actually the equipment efficiency has increased a lot, the energy efficiency. So we've done there's been a lot of progress, but there is just so much you can do. The thing is that RAN utilization is still inefficient. This is because in the past, what happened is that in order to make sure that you had good coverage and good capacity, what a lot of operators would do would be to over-provision the network, because that's the easier way to make sure every user has the right experience. Now, that strategy no longer works. And not only that, but we have better tools with 5G to manage the capacity and the power level to address that. So there is many more tools that we can use to optimize. So we don't need to over provision the network anymore. And what that one gives us, it's a huge scope for energy, for increasing energy efficiency using the same infrastructure. So you don't need to change to rip out the equipment, but you just use your equipment in a more effective way. Now, energy efficiency, however, once you look at it that way, it's how you manage the network. If you do not over provision it and you manage it, you need to start thinking about it in terms of trade-offs. So it's not just using some type of equipment that uses less power. It's more than that. You might need to do, you might switch power levels, and that will have an impact on availability, so you need to think about what are the implications of what you do. So you need to have full visibility into the impact of your choices. So not only you need a strategy, but you need to make sure that the strategy is actually doing what you want your strategy to be. So you need to have a continuous monitoring, you need to make sure you know what the impact is. And in fact, you want to know ahead of time before you make, you implement the choice, but you need to know and then correct and then refine it. Okay, so again, the strategy that you have to develop is also a strategy that includes and is grounded on the network evolution and use cases. And that is in order to do that, you need to think about what is the experience of the user. So you need to look at clearly what's going on in the RAN, what are, how much traffic you're managing, but also you need to think about what is the implication of your choices on your users. So you need to know what are the use cases are, what are your users doing, and also how does that fit in with your evolution as you move to 5G, standalone network slicing, support for new services. So this is all a lot to think about. And when you think about it, and this is why this is so fascinating, is that it's more than just getting the end number down. It's how you do it, because there are so many ways to get to that number. And it's a really interesting, we have, with 5G, we have a lot of tools that allow us to do that. And I'm gonna hand it over now to Frank, who will tell us more about what are these different ways to go about this. So said that, I would hand it over to Frank Mamani.
Thank you, Monica. Thank you very much. So first of all, my name is Frank Mamani. I work as a product line manager in VIAVI Solutions, and I'm in charge of our RAN assurance portfolio. As Monica mentioned, we are going to discuss about what options do we have in order to improve the energy savings from the RAN radio access network point of view. And for that, I will explain what are the different choices that we have. No? So I have divided the presentation in 4 areas. First of all, we're going to explain what are the levers that we have today in order to improve the energy efficiencies, right? Then we're going to go into a little bit of more details on what are the comparisons between these saving methodologies. And then we are going to explain what is the VIAVI proposal in order to do this in a better way using the geolocated information from our subscribers. And finally, I'm going to present a couple of examples from real optimizations that we have performed, achieving good energy results, energy saving results, but also improving the KPIs of the overall cluster. And finally, we will also see how this fits on the ORAN world. We know ORAN is becoming a hot topic. Many operators around the world are planning to implement this. So energy saving will be important during the once we deploy ORAN type of deployments. No? Okay, so as I mentioned, we are going to explain why the location intelligence from our own network is the best approach in order to achieve energy savings. So having said that, let's jump to the next slide. Here, what we can see are the options that we have today. What are the different levers that we have in order to optimize or increase the energy savings, specifically from the radio access network side? So if we think about it, what are the stages that we have in the network life cycle? In a very high view, we can divide this on the network planning, network operation, and network optimization. So in each of these stages, we have different levers that we can apply in order to efficiency the energy consumption. For example, in the planning side, many operators are thinking about sunsetting the legacy technologies as a way to reduce the energy consumptions. So this is a good method. And in the next slide, we will see more details about what we can achieve with this methodology. So this applies for legacy technologies, 2G, 3G, and even 4G. No? As Monica mentioned, sometimes we have over-dimensioned our networks in order to comply with the KPIs that we need to satisfy. But now this implies a high cost of energy consumption. No? So we can have a smart way of deciding which cells to switch off. No? So that's part of the levers that we can apply on the planning part of the network life cycle. On the operation part of the network life cycle, we can apply different methodologies. Some of them are features that are defined by the 3GPP during the latest release, release 16 and 17. We know that 3GPP has defined features that allow us to improve the physical layer in order to reduce energy consumption, but also they have defined use cases or functionalities in order to reduce this. For example, equipment and hardware efficiencies, spectral efficiency with the new feature that we see on 5G, like beamforming or massive MIMO. So as Monica mentioned, the spectral efficiency is becoming better in 5G. And we have other features, for example, pre-programmed shutdown of the cells or enhanced sleeping cell modes. No? So those are the levers that we can apply during the operation of our network. And finally, during the optimization of the network, we can apply optimization for RAN energy efficiency. We will explain with more details what do we mean by this. We can also apply during the optimization phase the offload of the traffic from the current networks, legacy networks, to the newer layers. No, in this case, probably 5G. So that's another way that we can offload traffic, and that way reduce the power consumption on the legacy networks. And finally, we have different some features that help us with energy saving. No? So on the next slide, what we see is a matrix with all the levers that I explained on the previous slide. So each of them, you can see here, each of them have a different scope, different advantages, and different limitations or complexities. No? So we are going to explain each of them, and then we are going to mention what are the VIAVI approach for deliver the best energy saving efficiency. Okay, so the first lever is the RF planning for energy efficiency. So the scope of this methodology basically is to start to switching off legacy layers, as mentioned before. This means 2G, 3G, and 4G, but in a smart way, no? In a way that doesn't affect the quality of experience of the subscribers that are remaining on this network. No? So this methodology, the advantage is that we can get the highest potential of energy savings just because we are switching off the radios. So that's the element that consumes more power in the network. But on the other side, it has many limitations because of the complexity of doing this on a traditional way. So if we want to switch off carriers on a traditional way, the next slide will show what we mean by complexities. Usually this methodology will rely on RF propagation models which require fine tuning for the algorithm to make sense, right? And there's a potential KPI degradation. No? And again, this will be explained on the next slide, but basically it's because there is a lot of correlation between the different parameters that we can modify in the network. So if I switch off a carrier, this will have impacts on the neighboring cells. So that's why we need to have an approach that gives us the visibility of the overall cluster that we are optimizing. The second methodology is the layer one software features. So as I mentioned, these are the features defined by 3GPP in order to enhance the energy efficiency and energy consumption on the RAN. Some of these features, even if they are specified by 3GPP, finally the vendors have the decision of implementing or not these features in their hardware. So that's why we said that these are vendor-specific features, and those type of features include, for example, micro sleep transmission, cell sleep, MIMO sleep, and symbol and slot shutdown. This is specifically at the physical layer, where we can get energy savings. So what are the advantages of this methodology over here? The second one is that in this case, this is reactive to the traffic dynamics. So those can be applied on a real network. They take effect on real time, which is good. The efficiency using multi-RAN is more visible in this case, and it's easy to activate, no? Because it's a feature that you can enable in the network. On the other side, the limitations, as we mentioned, this is technology dependent. Usually these type of features are available on the newest technologies, 5G, maybe in 4G, but definitely we won't find this type of features on legacy technology like 2G and 3G. So we need to find a way to better optimize the energy efficiency on these legacy technologies. Again, as mentioned, this is vendor specific, so not all the vendors will support these special features defined by 3GPP. Okay, then the third option that we have in order to get energy efficiency is the network optimization. So basically applying optimization on the radio network, we can reduce the energy consumption. So we know that if the RF environment is clean enough, then we can get more bits using the same spectrum. No? So that's what we call the spectral efficiency. And that's why it's a good approach in order to achieve energy efficiency. The advantages of this methodology, again, is vendor agnostic because it doesn't depend on the vendor of the RAN of the radio access network. And this is one of the methodologies that also delivers the highest results in terms of savings. The limitations on the other side is that, again, it's very complex. I have mentioned complexity 2 times now. The next slide, I will explain what do I mean by complex. No, it's a complex process if done in the traditional or manual way, right? Generally, this approach or this methodology requires or is based on counters or drive testing, which is time consuming, and in some cases this can be very expensive. And we can have potential, again, KPI degradation because of the interdependency of the KPIs. No, so I will explain this with more details on the next slide. No? And these 2 methodologies, the first one and the third one, the network optimization, they don't follow a subscriber-centric approach because we are using information like counters by cell or drive testing. No? So we don't know the real impact on the end subscriber. No? So that's a difference with the approach that we are proposing that we will show here. And finally, the 4th methodology in order to achieve energy savings is the application of the season features. So the scope of this methodology is to reconfigure the cell parameters in order to achieve energy efficiency. The advantages of this is that there is no manual intervention. We can enable those features in our network and they will run automatically. But the limitation is that, again, this is vendor specific. Not all the vendors support a feature for energy saving. And if they do, probably this will be available on the newer technologies. No? Okay, so in this slide, what you can see is we are highlighting the 2 methodologies that that VIAVI is focusing in order to achieve energy savings. The first one, the RF planning, how to decide to switch off legacy layers, but without impacting the customer experience. And on top of that, applying optimization that can allow us to reduce the energy consumptions. So the methodology that we propose using location intelligence from our network, they reduce the limitations that we are listing over here. So we automate the process of optimization, and we will see with more details how this is done using our approach. Okay, so again, I mentioned a couple of times about the complexity. You know, what are the challenges that we have when we optimize the radio network? Interdependency of the parameters. So I mentioned that the radio parameters are interdependent. For example, if I change the parameter in one cell, this will have implications on the neighboring cells. So those change of parameters can be a change on the tilt, on the azimuth, on the power. Now imagine the effect of switching off a cell. No? So this will have impact on the surrounding cells. So we need to take into account this when we analyze this type of proposals. No? So an optimization that is focused on different KPIs, they will also have different targets. For example, when we want to optimize voice, is different than if we want to optimize our cluster or our network for data. So those parameters will have interdependence. You know? So that's the challenge that we face here. Now is the high complexity. What does it mean? No? So imagine if we have different parameters to tune. As I mentioned, we can tune the electrical tilt, mechanical tilt, total power, the channel power, azimuth, heights, and so on. No? So then and we have many more other parameters if we consider handover parameters, power parameters, red selection. So if you just take into consideration 2 parameters and you apply the changes in a cluster of 100 cells, you will have potentially 10 to the power of 200 different combinations. So this is massive. This is impossible to do with a traditional approach of optimization. And the third challenge that we face when optimizing the networks is the dynamic nature of the RF environment. So in the past, we have done a couple of analyses in different networks, and we have discovered that 50% of the total data is consumed by just 10% of the users. So that's what we call the heavy users. And that's what is important to have a subscriber-centric view of the optimization in order to discover where those subscribers are located. Another insight of these analytics that we performed some time ago is that 90% of the total data is consumed in less than 5% of the network area. So in order to know the network areas, you need to know the geolocation of your subscribers. So this is not available with the traditional approach using cell information or planning data. So that's why we need algorithms that can work with these complexities and can deliver optimal optimization results. Okay, so the approach that we propose for energy savings, here we compare the traditional methodology versus our approach. So as I mentioned, the traditional methods include cell and network KPIs. Those are focused on network KPIs. So we can potentially have degradation on some quality of experience because we don't know the exact perception of the subscribers, while our approach includes the subscriber-centric approach. In the next slide, I will explain how do we get that subscriber-centric approach, right? So that gives us a richer view of the performance of the network, from the point of view of the real geolocated subscriber. The traditional method, again, potential degradation of the quality of experience when optimizing for energy saving. So if we consider that we will use the switch off of layers in order to reduce the energy consumption, we need to optimize the remaining cells in order to not degrade or even to improve the performance of the KPIs in our cluster. So this is, again, difficult to achieve with traditional methodologies, while our approach allows us to permanently switch off cells without impacting the performance of the cluster. In the traditional method, as mentioned before, we don't have visibility of the subscriber experience. In our methodology, we have full control of the quality of experience when we optimize for energy, and we have predictive capabilities. So we know what are the gains that we can expect in our cluster, even before applying the changes. So this is very good because you don't need to go and apply changes without knowing what the result will be. Okay. Sorry, but I don't have access to the chat window. If you have questions, you can write them on the chat, and we will answer them at the end of the presentation. So I have mentioned about the geolocation intelligence a couple of times. So what does it mean? So this is the core of our solutions inside VIAVI. We use the geolocated data from our real customers in order to do multiple things, in order to monitor the network, in order to troubleshoot the network, and in this case, in order to perform RAN energy optimization. So how do we get the information of these subscribers? It's basically, we process every single call of all the devices in the network 24/7, and this is what gives us the raw data in order to use in our optimization engine. So this information geolocated by per subscriber give us the information of where each device is located. So we can know exactly when and where the subscribers are located. What is the position relative with the serving cell and the potential cells. As you can imagine, this is super important for this kind of activity, because if we decide to switch off some layers, then we can know what is the potential serving cell that will cover that hole that will be created by switching off the cells. So we have this information from our real subscribers. We have the information of the RF measurements. We have the RSRP, RSRQ, and many different KPIs that are reported on these measurement reports to the network. And we have the geolocated quality of experience. We know how the throughput in uplink and downlink is performing. We know the drop rate and block rate. And in case if we have a VoLTE, we can know also the MOS, for example. So that way we have the real subscriber experience geolocated in a map. Okay, so this is what we mean by location intelligence. We leverage the geolocated information from our real subscribers in order to perform all the optimization activity. Okay, so now that we have understood, at least at a very high level, how do we perform the geolocation, here I'm showing what are the steps in order to use this geolocated data in order to get the energy saving recommendations by the optimization engine. So this is divided in 4 steps: the preparation, the optimization itself. Then we analyze the data because we can run multiple, multiple gain analysis to see what is the best recommendation. And finally, we can implement the changes in the network to see, to implement them and measure the energy saving. So during the preparation stage, what we do is what I mentioned. We collect, process, and geolocate every single event from the network 24/7 for all the subscribers. Usually this is done by processing what we call the call traces. These are files generated by the names, and names, and the traditional names in this case are Ericsson, Huawei, Nokia, Samsung, CTE. All of them can provide these cell traces, and those are the raw data that we use in order to do the geolocation and processing of the whole information from our customer. As part of the preparation stage, we also define what are the KPIs that we want to achieve. Besides the energy saving KPIs, we can configure what are the KPI goals and also what are the constraints. I don't want to modify the power, just the electrical till, and so on. So all of that configuration is done in the preparation stage. Then the next step is the optimization itself. The next 2 slides explain this with a little bit more detail. So I will explain that on the next slides. And then we analyze the results. As I mentioned, we can run as many activities as we want with different goals, KPIs, and constraints. So we can decide what is the best configuration that we can apply into the network, okay? And finally, implement the results. This can be done on an offline mode, so we can deliver the recommendations for the operator to implement, or this could be done in a closed loop. We can provide the APIs, so the recommendations per cell are fed to the OSS in order to finally decide to implement or not the changes. Okay, so if we focus on the right-hand side, we have the workflow of the optimization activity. This is based on what-if evaluations. So here you can see that the first step is to define the sites or cells or the cluster. So this is what we mentioned before as the preparation stage. In this stage, we also configure what are the allowed parameters to change. So usually the most simple ones to apply in order to optimize the network are changes on the power and the electrical tilt. But also in this case, since it's an energy saving optimization, we will choose also to switch off layers. Then the next step is to set the KPIs targets. So I want to switch off cells, but keeping the the drop rate in a certain level, the throughput in certain levels, so we can guarantee that we don't have degradations on the quality of experience inside our cluster. And then is the algorithm itself. The algorithm is divided in two steps. The hunter, I will explain how does it work. And then the digital twin in order to validate these recommendations. Okay, so during the hunter stage of the optimization algorithm, basically what we do here is to propose changes on the RAM parameters that we have allowed to be changed. No? In this case, for example, switching of cells, modifying the power of the cell, the electrical tilts, the heights, the azimuths. Okay, so this is done in this stage. But the beauty of the algorithm, this is not done cell by cell, but this is applied for the complete set of cells inside the cluster that we are optimizing. No? So that way we can achieve the best results for the energy saving proposals. No? So in case of, if we apply a set of parameters, the next step is to measure the impact. No? If the KPIs that we are monitoring, we think we can get further gains, then we look back and propose another changes in the parameters. On the other hand, if we see that we see degradations on the KPIs by that specific change, then we do the rollback internally and select another set of parameters in order to achieve the best configuration and the best gain for this configuration. So this step is called the hunter, no? To see what is the best configuration that we can apply in the network. Then the next step is to validate these changes with the digital twin. No? So basically, we have all the information from the network. We have the network configuration, where are the cell sites located, what are the azimuths, and so on. And we also have, as we mentioned, the geolocated information for all our subscribers. No? So that's the basis of the digital twin. So what we do in this stage is to apply all the configurations that we found on the hunter stage, and we apply them here, no? To see what is the effect of that configuration in each individual subscriber. So we can see what are the effects on the subscriber quality of experience, what are the effects on the subscriber services, does the drop rate increases or not, does the throughput changes, or does the RF condition changes. But now this is done not subscriber by subscriber, but this is done to the whole population inside the cluster that we are monitoring. So again, this will guarantee that we don't impact on any KPI that we have configured on the optimization activity. Okay, so those are the two steps on our optimization proposal. Okay, a question that we often get is, I already have a traditional optimization activity in my optimization cycle. No? For example, we are used to do parameter optimization, neighbor optimization. We have a song platform running on top of my network. So basically, this methodology that we are proposing is not replacing these other ways of optimizing the network, but it complements how we do it. No? So for example, once we have done everything that we can do using parameter optimization, network optimization, and changing the cell parameters, what we do with our optimized approach is to improve the overall baseline of the RF condition. No? So once this is improved, and in this case, using the energy saving approach, switching off layers, then once we have improved the baseline of the coverage and quality, then the parameter optimization and SON algorithms can work again, but using this new baseline of the RF environment. So this, what I'm trying to say here is that this methodology is complementary with what we have already in the network. Okay. And here I'm showing a couple of results from real optimization activities that we have done in Europe in two operators. In this case, I cannot share the name of the operator, but it's a tier 1 operator. And the request was to reduce the TCO using the RAN energy savings capabilities, right? Without degrading the subscriber quality of experience. So that means they didn't want to increase the drop rate or decrease the throughput. And this was performed on a cluster of 500 cells. No? So it was a decent size cluster. It was a VIP cluster. So the solution, what did it do? Is something that I mentioned is that in this case, you can see the cluster was based on 500 cells, but we not only use the information inside the cluster, but also what we call the monitored area. No? So the surrounding cells that are across the cluster. So in this case, we analyze, in fact, 2,800 cells. No? So the goal was to maintain the coverage, means to keep the RSRP and RSRQ levels without increasing the drop rate. And in this case, the optimization, okay. And in this case, the optimization proposed 18 different combinations to apply. No? So in this case, we modified 27 cells. We switched them off. 37 cells were decreased the power, and 20 cells were up tilted. No? And this gave the results of improving the energy consumption of the cluster by reducing 87 kilowatts per hour on this specific cluster without impacting the quality of experience. No? So you can see here the comparison of the KPIs before and after. This was done using the network counters. So these are the real impacts on the cluster. You can see that we reduce the energy consumption, but also we improve the downlink throughput. We improve the CQI. That means that the RF environment is cleaner, and we decrease the drop rate. No? This is the first example. And the second example is with Proximus. In this case, we prepared a white paper together with them explaining this approach. And it was similar. The customer requested that to reduce the OPEX, in this case on a 3G network, focusing on RAN energy savings. We focus on a cluster of 42 sites, and we delivered these changes over that you can see over here. No? And this allows us to achieve 2.4% of energy reductions. Okay, sorry, I didn't mention this on the previous slide. The reducing 5% of the cells, switching off cells in the cluster was translated on a saving of 230,000 euros per year only for that specific cluster. So if we extrapolate this to the whole network, you can imagine what are the levels of savings that we can achieve, right? Okay, so now I will jump to the ORAN way of working with energy saving. You know, ORAN Alliance has defined different features in order to solve the energy saving use cases. We can switch off cells, we can switch off carriers, we can switch off the complete RF channels, and we have advanced sleep modes as defined in ORAN Alliance. So in this case, the features that we could apply will be similar to what I mentioned, than the features defined by 3GPP on the layer 1 capabilities. No? So we can, all of these features can be applied on an ORAN type of deployment. No? And the main difference on an ORAN type of deployment is the way that we will get the information and the place where we will deploy our solution. No? So in a legacy type of network, our solution will be deployed on some VMs or in a virtual environment. But in an ORAN type of deployment, the energy saving optimization will be deployed as an XApp if it's deployed on the near real-time rig, or as an RApp if it's deployed on the non-real-time rig. No? So basically, the main difference is how do we get the information from the subscribers. No? In a legacy network, we get the information from the cell traces, and in an ORAN type of environment, we will get the information using the E2 interface. Those are new interfaces defined by ORAN Alliance, and the O1 interface. So we can request the E2 nodes E2 nodes in ORAN means the CU, DU. Now we can request them to report what is the load level, what is the traffic. And based on that, we can apply, or we can send policies to apply the different ORAN energy saving features. Okay, so in order to summarize, what are the key benefits from our subscriber-centric approach? It delivers the best optimization using geolocated subscriber information. So this gives us a granularity that allows us to get the best result. It allows us to have predictive analytics, so we can know the gains even before applying the networks, the changes in the network, sorry. And it's results oriented. The algorithm can save run energy cost with full control of the impact on the network KPIs and subscriber, because as I mentioned, we know even before applying the changes how the quality of experience will be affected. Okay, so in order to finish, what are the key takeaways here? As Monica mentioned, the energy consumption will keep increasing in the network, even if the number of subscribers are not increasing, but the new services and the new capabilities that we need to deliver makes the energy consumption to increase. No? Well, I don't need to explain the second one. The inflation in energy costs is affecting all the countries, not only Europe. So this is becoming a problem that we need to solve. We need to see how to reduce the OPEX and the CAPEX in the network. More energy efficient run is possible, but this can have a negative impact if not done in the proper way. And as we have seen, there are options in order to deliver energy saving and optimization results in general, in a more efficient way by using customer-centric and geolocated data and the right algorithms that allow us to minimize all the challenges that we have for optimizing the networks. So that's all from my side. Thank you very much. If you want the slides, please, you can send us an email, and I think we will answer a couple of questions.
Oh, sorry, I was on mute. Mark, thanks for the great presentation. We got a lot of, I'm also on video. We got a lot of information and detail, and we also got a lot of questions, and we won't be able to address them all. So you can, as Frank said, you can contact Scott, Neil at VIAVI, or send us an email as well. But we have a few minutes, so we will be able to go through some of them. So there is one question about densification. And the question reads, as operators need to densify their network, how do you see the integration with small cell and the optimization of power efficiency in the radio planning?
Okay, now that's a very good question. Densification, of course, is necessary in 5G, and even more with the millimeter wave, right? We know that millimeter wave will cover smaller areas, and that's why it's super important to place those small cells exactly with the exactly where the traffic is being generated. So if we place correctly, then we will achieve better spectral efficiency, and that way we can get energy savings, you know, by with the same hardware and with the same spectrum being able to attend more traffic from the network. So I think that's how we could achieve a better energy saving.
Yes, and no, another one. So I'm actually trying to go to the ones that are more specific. There are some very good questions that are more general, but let's try to go to the one that are more specific, and we have Frank online. And so the other one is, how do you shut down cells and enable cells back? And how much time it takes to get a cell back? Because you're not, since you're not relying on vendors.
Yeah, well, our approach, the one that I have explained here, relies on switching off the cells forever. So the algorithm makes the analysis and it detects which are the cells that if we switch off, we wouldn't have any impact on the quality of service of the network. But in case that you want to do this with the 3GPP features, probably again depends on the vendor implementation, but this can take up to a couple of minutes to put a cell on air again.
Yeah. Okay. Sorry. I didn't want to cut you off. Okay. Next, then I have a question for you as I was listening. Now, if you switch a cell off, this is a sort of follow-up question in this. Do you know which are the impacted users?
Yes. So again, as I mentioned, we use the geolocated information from all our subscribers, so we know where they are. We know which devices they have, so that way we can detect what are the affected subscribers if we switch off layers. No? So the algorithm takes into consideration that. So if we decide to switch off a layer, it's because there is another layer, another band that can take this traffic without affecting the overall performance. No? So yes, the answer is yes, we can know which are the affected subscribers.
Okay, now as I'm going through the questions, I see that there are a lot of questions in general about efficiency, power consumption, and 5G. And I think that there's a lot in there. We can't possibly cover it all. But I think that what I would like to say, that this is that it would take a whole hour to address that question. But what we're trying to say is that 5G as a technology is more efficient than 4G, but then it really depends on what your utilization is. So if you have a 5G cell that doesn't get any traffic, it's highly expensive and inefficient, and so is everything else. So especially at the beginning, you might see the cost go up for that cell because it's not, I mean, the cost per bit is high because you don't get usage. And this is why you need to think more than just the equipment, because you need to understand how is your equipment being not only deployed, but what is the usage associated to it. So the question is not for operators not to do 5G, they're looking for 5G. The question is how to optimize the use of energy given what you have. Okay, now we got a final question. Well, kind of a question that just arrived. It's given that cooling is such a big part of the energy consumption of the RAN, is there margin in the thermal metrics of locations and optimize them by processing at geographical locations that are cooler? Okay, so it's like, can you optimize cooling? I guess that's.
Well, that's a good question and a difficult one. Usually now the G0Bs are what we call distributed. So the baseband is located near the antennas. So that way we don't have to have we don't need to have a cooling specifically for the baseband, for example. No? The radios are also located at the antennas. So I think the new way of deploying the sites in a distributed way using the CU and DU can take into consideration this, but probably we will have to yeah, we can take this question offline, of course, to give more details. No?
Yeah, absolutely. And I guess that sort of makes the bigger point that there are so many ways, so many things you can do. And
Exactly.
With that, I think we need to move on. And I would like to thank you guys to attend. And Frank, thanks you for sharing your thoughts with us. And I will hand it over to Kendra.
Okay, great. Thank you, Monica. That will conclude our webinar for today. Thanks to our speakers for their great presentations, and thanks to the audience for those engaging questions. A recording of today's webinar will be made available please keep your eyes peeled for an email in the coming days with details on how to access the replay as well as the slide deck. VIAVI would be welcome to assist you in any energy savings assessments for your specific case. VIAVI has developed a specific ROI tool to conduct such assessments. If you have any questions or you'd like further information, please feel free to reach out to Scott Neal, who is VIAVI's Global Marketing Lead for Automated Mobility Solutions, and his email address is currently on the screen. Thanks again, and we look forward to seeing you at future events.
Bye. Thank you.
Bye-bye.